Well, thank you very much. And thank you for coming to this special seminar. And today we have our speaker, Chris Harle, who many of you know from his days at Fairbanks School of Public Health, but now he is professor and Chief Research Information Officer at University of Florida Health. And today he is going to share with us his thoughts on some very important issues. So interdisciplinary community for health data science, I think a lot of that's something all of us are, care about. So without further ado, Chris, I let you do your presentation.
Thank you, Wanzu. Let me share my screen. All right, can folks see my title slide here? Awesome. So yeah, thank you again for having me today. I know many of the people in the Zoom room here, and some of you I don't. So as Wanzu said, Chris Harle, I'm a professor of health outcomes and biomedical informatics at the University of Florida, and I'm the Chief Research Information Officer at UF Health. I have had the pleasure recently speaking to some of my old colleagues at IU, some of whom didn't know that indeed I'm no longer at IU, which has been kind of fun, as we've all gone to our basements and our Zoom rooms for the past year and a half. Indeed, I've been doing that from Florida in this exciting position, and just wanted to spend some time talking today about building data services, building community. So I'll just give you kind of my personal background, professional background, a bit of a spiel on that, give some context for the primary discussion items that I want to talk about. And they really boil down to two research informatics challenges that I see, and I see in colleagues and others around the country, and possible solutions. And I will paraphrase Brene Brown and say I'm a traveler and only sometimes a map maker, so I'm open to feedback. I'm walking this journey with many others as we try to figure out how we build community around data science and artificial intelligence, how we build better clinical research informatics processes. And so hopefully we can have a great discussion, and I welcome feedback as we go. So before I dive into what is more of a sort of administrative and operational research services talk, I'll kind of just context with my own research program background, and it really boils down to a series of studies and grants over the past 10 plus years now, focused on the translation from data to information systems to supporting decision making, which ultimately ideally is supporting human health. And so we've worked in all sorts of areas, beginning in developing machine learning models and data visualizations for communicating diabetes risk and translating that to patients, consumers, physicians. Spent a lot of my time in recent years looking at how we organize clinical data and information to support chronic pain care, how we build better EHR interfaces and decision support tools for chronic pain in primary care settings. And then more germane to what I'll talk about today, and my role as a Chief Research Information Officer has been focus, including publications, but also leadership and administrative work on collecting, validating real-world data to support translational research. So I also like to do and really, again, much of my work comes back to thinking about how we bring health and wellness by connecting people with better data information. So very much in line with the types of things that folks at Regenstrief and surrounding school medicine departments think about all the time. And the two sort of values that drive me and the teams that I work on and lead are really continuous learning and making a difference. And so I'm always sort of preaching and focusing on a continual learning process, because I think in an academic world, we are never finished. We are always pushing an envelope and moving to the next level. And then making a difference, and really making a difference at a few different levels. So in a perfect research project or a perfect research program, in my view, we are making a positive difference for the team members that work with us. We're making a positive difference for the organizations, be that an institute, a department, or a healthcare organization that we're partnering with. And then also, making a difference for the science as scholars. So those are the things that sort of drive me, and I try to focus on in my service work, my teaching work, my research, my administration. So over the past, I guess it's been almost a year and a half now as a Chief Research Information Officer at the University of Florida and University of Florida Health, been thinking a lot about how we organize people, process, and technology for health data science and AI research impact. And so there's a literature on this, as we know, and I'd be remiss not to mention, because much of it has been driven by many of the people at the Regenstrief Institute and at IU, both before their time at IU and now. But a lot of this falls in this domain, the subdomain of informatics, of clinical research informatics, which is really about informatics and the discovery and management of new knowledge relating to health and disease. And what I'll talk about today is really focused on informatics related to the secondary research use of clinical data. A lot of what I spend my time doing, trying to unleash the data, if you will, for clinical and health services researchers at the University of Florida and guiding teams who do this CRI work. And so the literature gives us some guidance on how we translate informatics to clinical outcomes, to clinical research, and produce real-world evidence. And over the past 15 years or so, with work from folks like Peter and Umberto and others, CRI has really emerged as this subfield with foci on things like research IT governance, the emergence of this CRIO role, which is relatively new, and really thinking again, how do we organize people, process, and technology in support of data-driven, real-world data-driven research? So sort of bigger picture context that imagine you all at IU and at Regenstrief are feeling just like we feel here in Florida. The real-world data is in high demand. EHR and other real-world data are in high demand, and that was before COVID. And then COVID happened, and then the crush, and we talked to colleagues around the country and CTSA institutions in particular, that the demand for data just took to another level a little over a year ago. So I think that's important context as we think about how we organize. And then there's this other trend. There's this wave of interest in AI and machine learning, and some of it is around really that machine learning modeling, the ability to do it is becoming somewhat commoditized in my view. And so therefore it's becoming more accessible to a broader range of research teams and organizations. And with that comes pressure to implement it. But that comes at the same time as there's serious concerns around bias in these models, the harm that poor quality models can cause, model drift as we operationalize these things into real life health systems, and sustainability. How do we sustain a pipeline of development and implementation and ongoing support and evaluation of machine learning driven healthcare delivery, for example? So there's this demand, there's this pressure, but there's also these concerns. And I think there's also this trend that I think we talk about in the informatics world, but I don't think we talk about enough in the translational science world of limitations and inconsistent data quality practices. Because as we turn out real world data for real world evidence, as we develop machine learning and AI models, ideally to implement and improve human health, we must start with high quality, well understood data. And I don't think we talk about that enough. So organizationally, just to give you kind of a flavor of what's going on at University of Florida, so you can sort of think how it's similar or different to what's going on at IU and at Regenstrief and the surrounding health systems. So UF has embarked over the last year or so on this artificial intelligence initiative, much of it driven by a $70 million partnership with NVIDIA, the graphics card maker, and NVIDIA donated tens of millions of dollars in hardware, and also cash to support faculty hires. And there's statewide dollars flowing in as well, with the goal of creating a campus-wide AI-enabled workforce. So goals of hiring 100 or more faculty, weaving artificial intelligence throughout the curricula of all of our colleges and departments, and using this massive compute power that has been donated. And so again, UF seeks to be this leading force in AI-powered research that revolutionizes the way we work, play, and live our lives. Down in our health colleges, so we are a really interesting university, or an exciting university, in the sense that our health science center is on the same campus with all of our other colleges. We're a land-grant university, but UF Health has 6 colleges that sit alongside the health system. And across these colleges, and I have the great fortune of co-leading this hiring initiative of 18 of these 100 faculty hires, to hire faculty and bring them into a community to advance AI methods and findings that are ideally reproducible, interpretable, generalizable, and actionable. And so in this AI hiring initiative, we're really focused on a community of scholars with AI expertise and experience, and also highly focused on infrastructure. And this gets back to my role as a CRIO and thinking about, as we hire in people who are going to do data intensive work, who are going to need access to data, to high quality data, who are going to need access to compute, how do we scale the infrastructure that enables their study and their research impact? And then we've also tried to uphold a value of diversity, equity, and inclusiveness, both in the research we do, making sure that equity is at the core of much of the research that's coming out of this initiative, and also that there's inclusiveness in the people we hire and in the teams that we're building. This is a quick overview, not one that you can actually digest, but this, for the hardcore data and IT folks, this is sort of a visual of our enterprise data warehouse for research at the University of Florida Health System. And the green database in the middle, if you will, we call our integrated data repository. It is loaded nightly from Epic as our primary data source, but it also is fed by many other clinical systems to create a real world data source that we use for all kinds of research, but also we use for operational reporting. So one of the exciting things that we do here is that we have a single source of truth for operations and research. And so as research informatics service providers, we've gotten good at doing things like I2B2. We're getting better at building pipelines to OMOP data sets. We are also looking ahead to beyond, but also building cores around waveform and telemetry data, around exposome data, around physician and other clinician access and use data, genetics, imaging, text we do fairly well with, but still a lot to grow. So we're building out these sub data cores on our team to really hit on some of these more novel and harder to handle data sources that we know researchers want. And then the final piece of context before I dive into 2 of the challenges is really sort of, in a nutshell, lived experience as a CRIO. So these, on the left side, you have researchers, and I still pride myself in being not just an administrator, but being a researcher and a scholar. So this is me half of the time. But this is also a lot of other researchers on our campus who, say, I have this idea, and all I need is some data from Epic, or all I need is some data from the enterprise data warehouse. I know it's there. Why can't they just give it to me? Or they say, I've trained a machine learning model, I've developed a model, I've validated that model, and I know it's going to improve care. I want to test it out. Just why can't IT implement it? Why can't we put this in? So those are researchers, and I know many of us, I certainly can commiserate with that mentality, and at times I feel the same way. But then on the other side of this bridge that I try to span and work to span with my team as a CRIO are IT and informatics staff. And I have the great fortune of overseeing a team of CTSI employees who are data analysts who work to pull data and provision data, and also IT staff who are part of the health system. Typically, the mentality, the perspective on that side is, yeah, I really want to help. I'm in this organization because I believe in the mission of research and innovation as well as good clinical care. But EHR data are really messy, and they're not necessarily designed for research the way we would design, prospective protocol for primary data collection. Can folks see my screen still? I'm getting feedback from Zoom. Good. Okay.
Yes.
And then on the other piece of this is, we also have sometimes misaligned needs of what the researcher wants or what their grant proposes to do versus what the operation needs to do in caring for patients on a day-to-day basis. And so those are things that we try to bridge and we try to reconcile, and it's a lot of fun, but it's also hard work. So 2 challenges that I hope resonate with some of the folks in the Institute, in the School of Medicine, and Biostatistics and Health Data Science. One is a process challenge, and one is a people challenge. And the process challenges really are thinking around designing data services, the operation of data services for research in the face of high and frankly, probably endless demand. And then the people challenge is really around how do we build an interdisciplinary data science research community so that we can create rigorous research and do so in the face of what I'll call an AI wave, or the hype of AI and that we want to accommodate, but also to make sure allows us to do good science. So in terms of the design of research data services, I'll give a little bit of literature background, then I'll jump into a framework that we're kind of working on and thinking about on our teams here. So Tom Campion and others have written about, many others have written about this, but this paper really resonates with me, really trying to describe the implementation facilitators and challenges in research data warehouses or enterprise data warehouses for research. And this is a nice paper in that it really gets into and interviews quite a few people in CRIO or other lead research informatics roles, and talks about their challenges and facilitators in governance and prioritization of data, tools and common data models as modalities for data access, challenges around accommodating researchers of varying skill sets, engaging and communicating and training users in the community who may be using the data that come out of our research data warehouses, and then coordination with other key partners on campuses like enterprise IT, like informatics teams, biostatistics, CTSAs. And so there really is this need to, it seems in the literature, to improve and share how we do this across institutions. And this has been ongoing for a number of years. And I think there's a continued need to share as the translational science world evolves, as the AI and machine learning interest and hype evolves. So again, kind of getting back to some of those challenges and opportunities we see, we have seemingly never-ending demand for research data out of our data warehouse. We have unclear and competing priorities often that our teams have to sift through. And we have fundamental differences in, I think, understanding across informatics teams who provide data and researchers who want to get their work done and are constantly asking, what's the process? How do I get data? Or just give me my data. Or on the implementation side, hey, didn't tell you all in IT or informatics that we wrote this grant, but we got it. And now I've got 12 months and $5,000 for you. So let's implement a machine learning model into the EHR, into clinical workflows, and see what happens. And that's a big challenge for an informatics team, as you might imagine. So this is a framework that I've begun to present internally and have not shared externally until today. This is how we started to think about our research data services and how we provision and provide data out to teams. 4 types of research data processes: vending machines, fast food, chef prepared, and personal chef. And this framework kind of helps guide our team. So again, it's a team, it's a team of data analysts who pull data from our warehouse, who write Python and SQL code every day, who work with researchers every day. And it guides us in how we process and improve around our data services and how we match research teams to data and tools that are appropriate. And when I say appropriate, I mean really mission aligned, aligned with having high quality impact on science. So vending machine tools and services, really, these are self-serve, these are quick and easy. We've seen these, I know we have these at IU, in the CTSA, and through Regenstrief. And these are valuable tools like an I2B2. They can do some quick and easy things like cohort discovery. In and of themselves, they're not particularly nutritious in the sense of would never advise a junior faculty member to write papers purely based on I2B2 queries. I don't think your career is going to go super far, but they have a role to play, and the cost is low. So vending machine services, low cost and useful for a narrow set of research tasks. Fast food research is the next level, or fast food services. I shouldn't call it fast food research because it's not to say it's low quality necessarily. Fast food data services, this is one where a data analyst on our team is going to require some effort from them, but they can pull these data fairly routinely and fairly reliably. And an example is something like, we can do a relatively simple cohort query, apply a relatively straightforward computable phenotype, and we can dump a whole bunch of historical data on diagnoses, lab results, medications, some labs, some meds, procedures, and demographics. And we can get that out to researchers on a relatively quick timeline. And frankly, some good science can be done here. And some good observational studies can be done here. And this is relatively low cost, but not quite as low cost as vending machine data services. And so one of the things that we're doing in our team is we're working to get better at, frankly, describing the menu of fast food data, because this helps when we work with researchers who are always like, I know the data's in there, just give it to me. And we have to continually educate and communicate that, yes, some of the data are in there, some of the data are well understood, well curated, and high quality, and we can get that to you pretty quickly. And other types of data we need to partner on. They're higher cost, they're more of a challenge. And so that's going up sort of our continuum. It gets us to the chef prepared type of research data service. So this is when a research team comes to us and they're asking for data that are not as well validated, not as well curated, have not been provisioned to as many research teams in the past. And they're going to take more validation, more thoughtful extraction effort to prepare and provide a good service, provide a good set of data that will ultimately be useful in a research project. So these are non-routine, and in many cases can be highly nutritious, well worth the cost in terms of research impact, if they're well designed. And this is where we preach the need for wrapping around that data service a clinical and or another health domain expert, a domain expert in a data type, because as we move towards more complex data types, like imaging data, like clinical text data, we need more nuanced data domain expertise. And this is also where our analytics, our statisticians and others, we hope to bring to the table, so that ultimately we have a savvy data user who has the analytic expertise to help design the data query, help design the data set that's going to be produced, and then execute the analysis on the other end. These types of data services also are ones where we end up having to provide more navigation support around things like IRB, because we may be pulling data or using data or sharing data that are unlike have been done in the past. Security and risk management, privacy, and enterprise IT often have to come to play. So there's a lot of overhead and wraparound service to our chef-prepared research data services to turn out one of these non-routine data sets, either on a single service or on a routine basis. And at the top of our sort of hierarchy is what I call a personal chef data service. And this is one where we're looking to partner with research teams. Our informatics, our IDR team is really looking to partner closely with research teams who are going to have an ongoing need for data, an ongoing pipeline of research data to complete their studies and potentially do things like implementation beyond just observational or retrospective work, but do implementation and evaluation. So personal chef type data services are kind of like the chef prepared meals, extensive startup oftentimes in terms of data validation and extraction before we can just give a team the data. Developing pipelines, for example, say out of our PACS system for images. And again, requiring navigation, data domain expertise, not just a clinician, but analytic expertise at the table when the data set is being defined and pulled. And so this really requires this ongoing partnership between our IT and informatics teams and the research teams. So not so much a vending machine, push button, here's your service, here's your data, but really an ongoing partnership so that we learn the taste and preferences that are needed to help an interdisciplinary team execute their studies. And so we talk about personal chef services though, because they're non-routine at first. And I think part of our path forward though is routinizing these so that we can provide data on an ongoing basis. And that requires, again, partnership and a really well thought out understanding and mutual risk between our informatics and our research teams. So some of the challenges we face on the personal chef meals, some people want chef prepared meals on a fast food budget. This is another challenge I know that we face in informatics when people write grant proposals and the informatics budget sort of gets overlooked or plugged in at the last second. And it requires a ton of communication and a ton of education of researchers who are going to be data users. And frankly, the fact that producing high quality real world data is not magic, right? And folks on this call know that, right? They've been pioneers in this space in many ways. But the communication and the education is an ongoing part of the work. So taking that framework, I want to talk about how we have started to think about managing the demand, the high demand, and the demand from diverse researchers in our university and health system. So one of the things that we started to do, and I've learned from Regenstrief that you do some of this as well, and in IU, we've tried to move researchers down this continuum from reusable, from chef prepared, everyone gets a customized data set, to reusable data sets, or you might call them registries. So how do we shift demand to lower cost options? Hopefully not reducing the research impact that they can have, but using things like common data models to standardize things like OMOP, and also building a community of health data science experts around our data so that we can hand off a standardized registry in a format that there is a team of analysts around them to pick that data up and understand its structure, understand its strengths and weaknesses. In our reusable data sets, and we started with the COVID-19 data set last year, we also work very closely with the Privacy Office, with IRB, and with our research IT teams to have these data, these registries ready to go, pre-approved. Anyone can have them for research purposes without a study-specific IRB approval. And so I see these data sets both as valuable for research teams writing papers and doing work, but also for trainees who are cutting their teeth on real-world data and developing their data science skills, and who we need to understand the nuances of health data. So moving down this continuum, ideally by reducing costs, but hopefully not reducing cost research impact. So that's one of the things that we're working on as we evolve our portfolio of data services. And an ongoing question, and I think this is one that folks at IU probably face around biostatistics and health data science and in the Regenstrief Institute is, how do we build a community of savvy data scientist users? And borrowing some terminology from operations management, when we're running these services, how do we accommodate researchers versus reduce our services? And so what does that mean? Well, that really means the terms accommodation versus reduction come from operation management. And it's really about when do we as data service providers make the data push button, make it easy to analyze versus what do we expect of our research partners? So a reduction in the service is saying, hey, here's the minimum bar and a well-described minimum bar of what data science skills or analytic skills a research team needs to bring to the table for us to provide them data and expect they will get good research value out of it. And so we talk about this a lot on our teams too, is, when do we accommodate a team in our services versus when do we reduce and say, here are the data in a standard format, good luck and Godspeed. Another sort of approach we're taking is trying to, as I said, foster more of these personal chef type relationships where we're going beyond one-off data sets with some of our really high-powered, well-funded teams and building really strong type partnerships where you start to blur the lines between the data providers and the research teams. This really has to be founded on mutual learning and understanding of the day-to-day challenges and goals of the data service providers versus the research teams, thinking of ways to build in shared risks and shared benefits, and building data pipelines that feed over time, including sometimes real-time data pipelines off of our EHR for teams, for example, who are doing real-time risk prediction of surgical outcomes. And so this requires a lot of organization and a lot of partnership, but I think it's frankly one of the only ways that we get to scale. So we can always ask for more resources, and we do. We need more data analysts, we need more compute, we need more storage, but we also need to build stronger partnerships because as I'm sure you're seeing at IU, we have teams whose data science work, whose AI machine learning work is just blowing up right now. R01 after R01 after R01, and this creates a massive demand for data, and the only way out of it is to partner closely across the teams. I'm going to take a breath and ask if there are any questions before I go on to the next challenge.
Chris, this is Sean. I think you're doing a great job of covering the waterfront. I presume we'll probably transition from challenges to strategies and approaches at some point. I'm just curious if that's the case.
Yeah, strategies and approaches come at different levels, I guess, Sean. Some of the approaches that we're taking, as I said, it's, and I'm happy to answer more detailed questions, are reusable data sets and registries, building a community around the OMOP common data model and the tools like Atlas and the data quality dashboards and others that allow our data services people to communicate well about the quality of data we have, to turn out data faster. And then these partnerships, structurally, what are we doing in some of these personal chef partnerships? We are embedding research team members in our IDR team, our IDR research services team, doing that in a way that is sort of privacy and IRB compliant, where there's still some arm's length, but also bringing the research teams closer to the data in that regard. So those are some of the things that we're doing. What other questions do you have, Sean, around specific solutions?
I like the language you used around creating a community of data scientists and how we go about doing that. And you alluded to a couple of things there, bringing them onto the team. But I think there's a real opportunity there, and I'm just curious to hear. And it's fine if maybe this is a conversation for another time, but thinking about how do you create a community of highly motivated, highly innovative, creative data scientists who often do view data simply as a commodity that they just need more of. But instead, how do we build a community that can help make this better? Anyways, I think there's some food for thought there.
Yeah,
Yes.
no, I agree with you. Yeah, go ahead, Wanzu.
I was just going to make a quick comment. I like your food analogy here, but my suspicion is we're going to need vending machines and we're going to need personal chefs. The problem is the way we deal with the data are quite different, and how we handle the data are going to be drastically different. So I think the community needs to have a very robust component with the methodology and how to deal with these various types of data. Of course, the strength of evidence will be different too. So all of these together, it's going to be a complicated structure, I would think. I wonder what's your thoughts on that?
Yeah, no, thank you, Wanzu and Sean, I think, for teeing up some of what's coming next. In our research, our IDR team, which I think is most equivalent to a data core at Regenstrief, we're recognizing that there is fundamentally different, we want to some degree, centralize a source of truth, but we also recognize that there are different types of data that require unique expertise. So we are aiming to build out a text core that's really focused on notes. We're aiming to build out an imaging core that's really focused on imaging data. We're aiming to build out a genomics core and a waveform core. And each of those is going to require a unique set of, and we're aiming to build out an implementation core as well. Each of those is going to require data domain experts, because it's, frankly, as we know, serving up these data in a responsible and useful way is not the same as serving up structured EHR data. The challenges we have with an IRB or a privacy office differ with each of those types of data. So we're aiming to build out cores that have faculty leadership, and I think this is important, or a PhD level leadership around a certain data type, its generation, its quality, its protection, and then data analysts who begin to specialize in different types of data so that they can partner well with the research teams that are going to consume these and do analyses. So that's some of the structure that we're building out in the forms of these sub-cores, if you will, or these cores. And I believe strongly, and I've been trying to compel our deans, so I get the great opportunity to work with all deans of all of our health colleges on a regular basis who are hiring. They're in a hiring spree around our AI initiative. And I've trying, we will see if it works, but to really make the case, which I'll talk about in these coming slides, that to scale up, we need people who are close to the data, not just people who are consumers of the data or analysts of the data, but roll up their sleeves and get their hands dirty in the data at the source, who roll up their sleeves and get their hands dirty at understanding how the data are generated coming off of a health system. Because we know that has implications for analytics, be that traditional inferential, statistical work, be that prediction modeling. I've said, I think if we at the University of Florida in our AI initiative, if we hire 100 faculty or say 30 faculty who are in our health colleges, all of whom purely want to be consumers of data, we will be crushed under the weight. And so we've been talking a lot about sort of unique faculty appointments faculty who have a 20% role or a 30% role in an operational unit within our health system, be that IT, be that our informatics data core, or be that maybe in quality or other places, so that they can help starting with the data, which is the foundation, so that they can really help and be part of that, as opposed to just having the approach of give me the data so I can develop models. And so that'll crystallize here in some of these next few slides. So as I said, at UF, we are hiring all of these people, including, it's looking like it'll be 30 or more people in our health colleges, faculty, in these sort of overlapping areas who are going to advance AI for healthcare delivery, AI for public and population health, AI for biomedical discovery. And we're doing this, and perhaps we'll reflect on this one day and say, wow, we never want to do this again, but we are not hiring any of these people at a start. The hires do not happen in a department. All of the initial screening and coordination happens across college. Ultimately, these people will live in a department, perhaps with joint appointments, but we're trying to operationalize in the hiring more of a community, a less siloed approach, because we know data science and artificial intelligence cross, and many of the people can cross disciplinary boundaries. We talk a lot about, we spent a lot of time talking, well, what even is an AI researcher in the health sciences, and what is the right mix of phenotypes of researchers? We talk about 3 different phenotypes as we're soliciting applications and screening applicants and looking to hire. The first one is an AI application and translation. These are people who are going to study the application of existing methods to health-related practices. So these could be coming from a variety of backgrounds: clinical science, public health, social science, informatics, or implementation science. Our second phenotype is more the methodologists who have expertise in the theory and the mechanics of AI tools. These could be people who are statistically trained and have moved it more into AI or machine learning. These could be computer scientists. These are people who are hopefully recognizing the novelties in health-related data apropos to the AI mechanics, the ins and outs of real-world healthcare data before we start running models or developing and validating models. So, and we're looking at people with engineering backgrounds, computer scientist backgrounds, and of course, people with biomedical informatics backgrounds. And then our third phenotype, it'll be interesting to see if as this community develops, because we're really in the early stage of this hiring initiative, are really out on the frontier, and we're asking, can you bring an AI pioneer into an applied college, a health science college, people who are doing high-risk research with even more basic science methodologies, for whom there may be a longer-term investment, a longer-term horizon before getting a return. People maybe for whom their focus of research today is tangential to health sciences, but perhaps not tomorrow, and can really push us out onto the frontier of AI ultimately improving human health. And so I think getting a little bit to what Sean and Wanzhou had talked about is, what are some of the challenges and opportunities to build these teams, build these communities? We're doing it in staff. In some ways, I'm working on teams that are building out staff community, data scientists, but also faculty hiring across our colleges. So how do we build, incentivize, and reward interdisciplinary teams? I would posit, and I would love feedback, that there's, in this sort of space right now, there's an overemphasis on the model building, the predictive modeling, building, testing, training, validating skill set. and an underemphasis on people who are knowledgeable of data generation and data quality. And an underemphasis on ultimately, what's the point of this model? What's the point of the tool that we're going to implement? Is it actually going to have an impact on health? And as I kind of alluded to before, I think one of our challenges is I think we're disconnecting our infrastructure builders from our data service providers. So disconnecting our IT people and our informatics teams, our data warehousing teams, from clinical operational teams and from research analysis teams. And so how do we create those partnerships in a way that we're more connected? Because the work we're doing is ultimately going to be interdisciplinary. It's ultimately going to utilize and will need to be real world. So one of the things that I've really been trying to push, as I said, in our hiring initiatives, in the way we structure faculty appointments and the way we work on teams is really this focus more on what I've been calling the first mile and the last mile. And that first mile is all about the data, right? Data are our lifeblood, and bad data leads to bad models, leads to bad decisions, leads to bad science. And that's hard for at times when we want to do things fast. We want to get data out. But I think we need to advance the data science and really incentivize teams and service providers to produce really high quality data, to advance the science of data, real world data validation, linkages, standardization. In this vein of what the NIH and its Bridge to AI initiative that's starting to hit this summer is saying data forward research, not hypothesis forward research, creating really high quality, well understood, fair AI and machine learning ready data. That's the first mile. And the last mile is the human interface between our artificial intelligence or our machine learning. And this really brings in the skill sets of implementation science, decision science, clinician science, and health services research. Because ultimately, somewhere along this translation from data to human health, there's a human in the loop. And again, I would posit, and I would love feedback, that there's too much hype in the second mile, I want to build a model now, I want to train a model, I'm trained in modeling and in machine learning, without executing those methods, without thinking about the data. And we're seeing it, for example, in our hiring initiative, where that's where the hiring committees are tending towards people who are computer scientists who may not know healthcare data well. And so we're asking, how do we support them on the first mile? And then we're also seeing teams that have been developing models that are intended ultimately to be embedded in healthcare delivery, but without the wraparound human factors engineering or implementation science support to take it to the last mile. So I think this focus on the first and the last mile is fundamental in building this community. And there's education and training needs, there's hiring needs, there's creativity in how we structure people's appointments. And then there's a recognition of the value, frankly, the fundamental value of these different phases, from data to health. So how do we ensure training, hiring, rewards, and scientific advances across this continuum, I think is a challenge that I see in our institution, and I'm curious if you all see it at IU and at Regenstrief. Last up, and then we'll leave it to discussion. These are some of the concrete things that we're really trying to kick off as we bring in all of these people and new services to the University of Florida. What we're calling AI Community Fellows, and thinking about 12 to 24-month appointments. So there's an honorific attached to this, and we take existing faculty from across our colleges and we appoint them AI Community Fellows, and we give them space and we give them almost like a mini sabbatical in some sense, as an interdisciplinary cohort to really speed up and do some fast-paced, more agile type approaches to advancing applied artificial intelligence and machine learning science towards improving some important health problem. The other thing that we're aiming to do with these fellows is provide them really wraparound support in the way of navigation of IRB, privacy, things like getting data use agreements done, all of these other sort of operational challenges that we see stymie researchers on a day-to-day basis, security and risk assessment. So we're looking to launch our AI Community Fellows program, likely in partnership with our CPSI. And then finally, trying to broaden our concept of and our commitment to academic service, if you will. Broadening that to data service, to IT service for people who are data scientists, for people who are informaticians, for people who are statisticians, more faculty who bridge between an IT unit or an operational unit like a data core or an integrated data repository team. And really bringing study designers and analytic experts closer to that data generation. So again, so that we're finding ways to partner such that it's not just, here's your data, good luck and Godspeed, but having the full spectrum of data scientists at the table as those vending machines, to your point, Wanzu, and those partnerships are solidified. And frankly, this has implications for P&T. This has implications for junior faculty development, because we have to have career paths that reward this type of service if it's going to work. So that if the incentives are still completely pulling towards plant your own flag, be your own unit, and have your own fiefdom, I don't think we can fully operationalize these sorts of things. And so these are a lot of the things we're wrestling with, and we're getting a lot of great support from our deans at Florida to experiment with these kind of structures with our people and our process and our data and technology. So I'll just leave it here for discussion of these are some of the things that we're doing, and excited to share and learn your thoughts as well.
Thank you, Chris. This is a wonderful presentation. I think you raised some very profound questions or issues that we face today. And maybe I would just take this opportunity to make a comment. You know, in your 3-mile model, and I think each one of us tend to just operate in one of these spaces. So we understand, we see what's the immediate surrounding of our operation. The key challenge I see is to connect people together, and because it takes a larger team. And I want to hear your thoughts on, you know, how best to do that. Is it driven by maybe a common scientific interest? I mean, I at least tend to think that way. You know, you bring people together just to solve a specific scientific question, or is it there are some other ways to just provide the general structure so that people explore and come up with better ideas? I don't know how you think about these.
Yeah, no, this is a great question, Wanzu. Thank you. And I agree. I think it is about connecting people first and foremost. And some of it is incentives, right? The way our PMT is structured, the way our rewards are structured. But I also think that, look, many of us went into science. I would imagine most of us went into it because we were idealistic about making a difference, and still are. And so I do think it needs to be problem driven, right? And I think we can rally around a common problem. And when members of our team lose sight of that, it can be hard, right? You know, we just hired an assistant director in our data core, and one of our analysts was, you know, lamenting, you know, no one ever says thanks. No one ever says thanks for the data. It is always, where's my data? And then you never hear from them when it comes. And then somebody said, yeah, imagine running an email server, right? You really never hear, you never get thanked if you're running an email server. But we're not there yet either in terms of the quality of the data and the robustness of our data for generating good science. So we need, I agree, focusing on problems is a way to is a rallying point, and then having interdisciplinary teams, because the people who are going to be taking primary responsibility for analyzing the data have a lot to say about how those data are formed and how they're validated in terms of their quality and how their data quality can be improved. And the further down to the 3rd mile, the clinicians or the implementation scientists who might be using these data and evaluating their impact on an outcome, they have a lot to say as well. if we're going to create the best science and truly have impact. So I think it is connecting people, and frankly, just learning and listening to each other across these silos. We don't do enough of that. We say, where's my data? And then we move on. Or we say to the statistician, where's my analysis? And then we move on, right? And that's a challenge.
Great. Chris, can I pose two questions for you to take in either any direction you'd like to go?
Sure.
Okay. First is, at University of Florida, you describe this great interconnected relationship between the operations team and the research stakeholders in a very closely knit or close-knit or proximally knit relationship. Given what you know about IU and IU Health, I'd be curious to hear your thoughts about the advantages and disadvantages of the IU to IU Health organizational ties, and how that may or may not influence what you've discussed today. That's number one. Number two, would you agree that in the context of finding a good problem, would you agree that a problem stated as the following might be a unifying call, and that problem is there aren't enough eyeballs on the data, and we know that there are discoveries in the data that can change the world. The challenge is we need to get it to more eyeballs. Do you think that is a rallying enough cry, vision to create community?
Thanks for the easy question, Sean. I appreciate it as always.
Like I said, take it any way you'd like to.
I expect nothing less from you, and I thank you for these. I'll start with the first one, right? So, yeah, I mean, I will admit, and I think you alluded to, I mean, structurally, our academic health center here is different than what's in Indiana. We have some great sort of organizational structures that they're increasingly connecting the academic units to the data and the operation, although we also face some of the challenges, right? Some of what I'm presenting is aspirational and not fully operationalized. And so, I mean, I would argue to have, thinking about the Indiana environment across, different health systems, but including IU Health and including, for example, Eskenazi, I think that integration, that's a worthy cause, right? Continuing to say, how do we integrate the research teams across the operations so that they truly understand how data are generated, so they truly understand how clinical process happens and how IT process happens. I look at people like Randy Grout. I don't know, Randy, if you're on here, but, I think we need more Randys. Who are spanning the clinical and the informatics on the health system side with the School of Medicine and the Institute. And I think really, really hard and requires leadership commitment in all parties. But I think that has to be part of it. There aren't enough eyeballs on the data. Is that enough rallying cry? I don't know that it is. If I can just sort of off the cuff. I like the idea of getting a lot more eyeballs on the data. I think one thing, when you say that, I worry that means more data faster. And if it's more eyeballs on the data to vet and validate and ensure that it's high quality research grade data, or that we're applying the right methods to deal with the flawed data, I think that's fantastic. If it's more eyeballs on flawed data without a description of those flaws or an understanding of those flaws, I get nervous. And I think part of the rallying cry, and maybe this is where you're going with it, Sean, has to be, I guess you said it, right? Eyeballs on the data because there are discoveries to be made, right? I think the discoveries are really, have to be a part of that rallying cry.
That was intended.
Has to be part of the rallying cry.
Yeah, that was
Yep.
intended
Okay.
to be the primary focus. Eyeballs are a tactic to achieve the ledger goal. Yeah.
Yep. Yeah, I like it, but the first mile can't be lost. Again, I think, you know, when I think about people I interact with sometimes these days, it's like enamored with the ability to create a reinforcement learning model or a convolutional neural network, and that just sounds fancy, and that's what they want to see more of. What doesn't sound fancy is data validation, data characterization, but there's a science that needs advanced there as well if we're going to have the end impact.
Great.
Thank you. You said it well.
Any additional questions? We have a few more minutes. I think we can have more questions. Well, if not, I think, you know, there are lots of things that, Chris, I think your presentation give us a lot of things to think about. These are some of the fundamental issues we're all struggling with. But thank you for sharing your thoughts. And this is truly great that we hear all these things. And if we don't have other questions, I would, you know, again, thank the speaker. Thank you, Chris. And for people who have additional questions for Chris, I'm sure you know how to reach out to him. And, but again, thank you, Chris, for the wonderful presentation.
Yeah, thanks folks for having me. I enjoyed it. Great to see many of you who I haven't seen in a while.
Great. Thank you. Bye-bye.